Right, hello, welcome to a lesson on encapsulation and polymorphism. Before we go too far down that road, I have a warm-up question for you. Actually, I'm going to do a couple review things here before getting into the main lesson. So this is taken from the house ball league a couple students had last year, Carson and Cole. So I make some different objects here, a Cole and a Carson baller object and a crowd object. There's no right answer to this necessarily. Just take your best shot. So pause the video and take a guess at what you think is going to be displayed by this code before continuing. All right, so we create the baller objects, and then we have Carson miss a shot, miss another shot, miss a layup, followed by Cole dunking. All right, so we can guess at this point the decibels is going to be pretty loud, even though the crowd only technically has me, but maybe there were some more people in the crowd too that weren't shown in this code. But anyways, we're going to say the crowd goes nuts, so about 85 decibels. Again, there's no right or wrong answer for that. Carson's shooting percentage, this should be, assuming that he has made no shots in the beginning, he miss, so he's 0 for 3, so his shooting percentage should be 0. So the Carson object would have a shooting percentage of 0 because it missed all its shots at this point. Okay, so a couple more review things, just trying to differentiate between classes and objects. So we've done this scanner scan equals new scanner system at n. We've done that a bunch. Is that an object or a class for the scanner? All right, and then thinking about how we use scanner, what are some methods and constructors that must exist inside of scanner? So go ahead, pause the video and give these a shot. Okay, so this would definitely be a scanner object. All right, anytime you do the new keyword, you are creating a new instance or new object of the class, right? So somebody else wrote the scanner class, right? We didn't write that, we're just using it. And so here we're creating a scanner object, right? And then once you have that object, you can just call the name dot whatever. Okay, and that kind of answers part 2, where all the things you can do here, next line, scan dot next int, right? All those things must be methods. Okay, so some methods that this thing must have are like next int that returns, I guess I could do the return type here, int, next int, all right? It must have that. It must have a string that does returns a string from the next line method. There's a Boolean one that's like has next int. I don't know if you remember that one, but that would also have to be in there. So there'd be a whole bunch of methods. You can actually look them all up on the intranet if you want to. But that's just an example of a few. And then as far as a constructor goes, okay, so we don't know exactly what it looks like because I don't know exactly what type of thing system in is, but basically it would have to have one that goes public and then scanner and then takes in thing we want to scan, right? That's the system.in part. So there must be a constructor that is public, scanner, and then whatever the heck type of object this is, type of variable that is. And I'm not sure what type that is, but basically there must be a constructor that looks like this and has some sort of input parameter representing what we want to scan. Okay, so goal for today is to understand, these are some crazy terms, encapsulation, polymorphism. Honestly, I have to look them up sometimes. I guess now that I have taught this a bunch, I'm a little more familiar with them, but they're just kind of big words that are kind of scary and stuff, but the hope is to make them a little bit less scary by the end of this lesson. So that's our goal, is to understand encapsulation and polymorphism. There's not a lot for you to do coding wise here. I'm just gonna, you can jot some notes down here, and then I'm gonna have you do a summary at the end. So that's kind of what this lesson will look like. Okay, so encapsulation. This is a definition I looked up on the internet. The bundling of data with methods that operate on the data. So this is tied very much into chapter 8, where we're building our own classes. And so when we build a class, we have to define kind of 2 things. Technically, you could include constructors in here, but constructors are just sort of like a special type of method. So basically, you want to define the data members, which I often call like the instance variables. So that's the data we want to track. And then the methods, all right, the different behaviors. And so I thought this was just a good picture. Like encapsulation means you have a capsule. And so we have a class right here, and inside of that class, there's just two pieces. You have a bunch of little variables and then methods that like interact with those variables. And again, where the constructor could be a special type of method. Okay, so that's basically a class encapsulates those two things. It includes those two things, right? And normally, again, a class will represent a real life object. Like I'm looking at a bunch of books right now, right? So a book might have like a number of pages. So the variables might be number of pages, the author, the publisher, the copyright date. Okay, and then there might be a bunch of methods like we could do read page or turn page method or get author, get copyright date, right? So we could have all these different ways to interact with the book. Okay, here's another encapsulation example just from class, right? When we made the superhero class, that's kind of like a capsule that has some data and methods, and we had to define what data we want to track and then what are the different things we want to do. Okay, and I added a few in here, defend and attack. I know we didn't do those, but basically that's the idea. Is you when you make a class, you have to define those two things. Okay, and so sort of the power of this idea of encapsulation is once you make the class or someone else has made the class, you don't necessarily have to understand all the working. So when I think of this capsule, it's kind of like hides whatever's inside of here because once it's working, you don't really have to know the details. Okay, so again, if we go back to scanner, when I do this scanner, when I call next line and next in, I don't really know how that works. All that information is encapsulated inside the scanner class, right? So once we create an object of the class, we don't necessarily have to know how the class works. Okay, so I did another example. One time for my phone, I wrote a Spotify app that would play songs on Spotify. And so this was another good example of encapsulation. So somebody else created some Spotify classes, right? Like maybe there's a Spotify player, and then it defined the data and then a bunch of methods. Okay, and so all that information is encapsulated inside of their class. So when I use the class, this would be me creating an instance of the class. SP would be an instance of the Spotify player class. I didn't have to know all the details. I could just call the methods. So like Spotify player that login, so I'd log in with my username and password. I could load up a song with the title and the artist, and then I could do call play song and then rewind it to play it again. So I did a little for loop here so I could play Baby 10 times by Justin Bieber. And so this is part of the idea of encapsulation is all that information is encapsulated inside of the class. So I don't really have to understand how that code works. I just have to know how to call the methods. All right. And this is actually an oversimplification. It was a little bit harder than this, but I didn't want to get too deep into the weeds here. So this is just kind of the rough idea, and it's not too much harder than this, to be honest. Like once you understand how to use the objects, all the other information is encapsulated inside of there, so you don't really have to know how it works. Okay, so polymorphism. I looked it up on the internet. So the top part here is the internet's definition. So poly just means many and like morph, right? So think of like many ways to like morph into something different. Okay, so it's the ability of different objects to respond in a unique way to the same message. So to me, it makes more sense to just explain it with an example. So in my head, I think of polymorphism, it means like you could have a dot roll method that would mean something different to a die, like a dice from a game, a board game, than it would for be an acrobat, like an acrobat from a circus. So roll for a die might mean you roll it and it returns an int. The acrobat, if you tell it to roll, it might do a flip or something on the screen or something like that. Okay, so the dot roll can mean different things to different objects. All right, that what single method can mean different things. All right, and this is getting a little bit into chapter 9 here, but the idea is if we have like a few animals, right? So you might have a dog and a class, sorry, dog and a cat. So make sound will be different for a dog. It'd be woof woof versus cat, which would be meow meow. So that make sound method is different for each little animal class that we make, right? And that's an example of polymorphism where make sound means two different things. And again, this is a little bit ahead of ourselves. So this is actually chapter 9, where this is called like a parent class. And then these are called like child classes or subclasses. So this is like a super or parent class, and these are subclasses. So basically just these classes are specific types of animals, and we'll dive more into that in chapter 9, but I just thought I'd explain that a little bit here, give you a little preview, little extra bonus learning. Okay, and here's another example is you could have a shape class, and then you could have these little subclasses like circle, triangle, and rectangle. And then when you do an area method for each one of those, it might be slightly different. All right, so that area means something different for circle, triangle, and rectangle. And that's just another example of polymorphism. Okay, so to help you kind of make more sense of this, I want to get a little more practice with these concepts. So there's a summary that you'll do on Schoology. You'll have to summarize encapsulation polymorphism in your own words, and then answer some questions about is it encapsulation, polymorphism, or neither. So give that a shot, and then I will look at the responses and give feedback based on what we struggle on. So that is it for our lesson. Again, our goal is just to define these two terms. They're crazy big terms, but hopefully after this you have a little bit of sense of them. If you're still confused, you could maybe do some Google searching. You can check YouTube, look for some definitions on Google. Because the thing for you is to make sense of these in your own head. So they make sense to me, but I'm always not sure if my explanations are good enough. So seek out other resources as needed. Thanks for watching.